Crocky, good day, and welcome to GeoFest. My name is Max, and I'm not doing that for an hour. As much as I love Steve Irwin, I don't think that I could keep that up the whole time, so I'm not going to. Like she said, my name is Max. Today I'm going to be assisted by Madison over here, also goes by Matt. She is my partner in life, science, crime, and in the cowboy way. And Blue Boy, our little mosasaur, who will also assist us. So to start us off, who here has seen these vehicles since they've been in the park? A few of you. That was us, actually. So we've got the Crittermobile and Claude Dam Van is what we call that one. While these are definitely the coolest vehicles in the park right now, sorry to any Lambo owners out there, unfortunately they're not ours. They are museum vehicles. We do work for the Sternberg Museum of Natural History in Hays, Kansas. We are currently helping teach their science camps, which are for middle and high schoolers. So next summer, if you've got a science-obsessed kid, keep that in mind. If you recognize me, it is either for my social media presence with Madison here. We have reached millions of people on social media. I've also reached a couple of people by being in PBS's Walking with Dinosaurs last month. That was kind of a dream come true. I was in the episode about Pachyrhinosaurus, that's this guy, which is not only my favorite dinosaur, but one of the animals that I get to study. But that's not what I'm going to talk about today. I'm going to talk about a different animal. Sure, I talk about science on the internet and sometimes on TV, but why does that mean that I am an authority? After all, there's a lot of people who shouldn't be talking about things that do on the internet and TV. So I, like was demonstrated, I have a BSc in geology, but I also have an associate in general science, and next month I'm going to have my master's in paleontology. I have a lot of work experience. Oh, thank you. I have a lot of work experience in conservation, in geology, and of course in paleontology, and I have research in all of those things as well. I would identify as a paleontologist first and foremost, which I know might have some people scratching their heads. Isn't this a geology festival? Well, actually, paleontology is a geological science and a biological science and every other kind of science mixed in as well. Paleontology is what I like to call the most interdisciplinary science. It's essentially detective work for life in the past. My specific brand of paleontology is known as paleoethology, which basically means that I study extinct animal behavior and how it evolves. Excuse me, I'm going to take a sip. And while I study a diversity of animals, my main thing that I'm studying right now is mosasaurs. How many people have seen the Jurassic World movies? Yeah, so you're probably familiar with mosasaurs. Thankfully, I don't have to go through and define what a mosasaur is as often, thanks to those movies. They've kind of made them a household name. However, they have also given me quite a bit of cleanup, because there's a lot of misconceptions that have been presented by those movies. Especially by the most recent one, where this guy, who is the paleontologist in the more recent one, refers to mosasaurs as dinosaurs. They are actually not dinosaurs, and we'll get a little bit into that. They're also not that big. They kind of portray them as being blue whale size. Horrible. They also portray them as mob bosses for Spinosaurus. I can't even begin with that one. They're not crocodile looking. And they are certainly not capable of belly flopping onto land and then moving back into the water like an orca. So if mosasaurs are not dinosaurs, what are they? Does anybody have a thought? Anybody who's not a paleontologist, at least? Yeah. They are a marine reptile. So there's a lot of different kinds of marine reptiles. In particular, mosasaurs are lizards. The largest lizards in some cases that ever lived, actually. So mosasaurs are right up here with well, in this one it says lizards and snakes. Fun fact, snakes actually are also lizards. They're just highly specialized lizards. There's a little bit of debate over whether mosasaurs are closer related to snakes or monitor lizards, but regardless, those snakes and monitor lizards are already pretty closely related anyway. They fit into a group of lizards that are called the toxicophoran lizards. That's basically any lizard that has the potential to be venomous. It's unknown whether mosasaurs are venomous or were venomous, so basically that's the main thing that we need to know, is that mosasaurs are toxicophoran lizards. Big misconception is that dinosaurs are lizards. I know, their name means terrible lizard. That name was given to them in the 1800s, so let's not rely too heavily on that one. Modern science is a little bit better than it was back then. So mosasaurs are a highly diverse group of animals. The largest, Mosasaurus hoffmanni, was about 56 feet long at the highest estimates, and the smallest, Dallosaurus, was only about 3 feet long. So there is quite a range of those mosasaurs. We know of at least 70 different species now. We will probably continue to know of more as time goes on. While they were very various in size, between 3 and 56 feet, which is a huge difference, once again, they were not the size of blue whales, like in Jurassic World. So I want to put that one to rest immediately. So mosasaurs lived exclusively at the end of the Cretaceous period. So that is the end of the time of the dinosaurs. They kind of lived alongside things like T-Rex or Triceratops and went extinct with them as well. This is actually a remarkably short period of time for an animal to exist, only about 30 million years, which on the geologic timescale is not very long. As it says here, I was going to try to quiz you, but then I realized I actually wrote it down. The Earth is about 4.56 billion years old. So to put into context, because while I love this ray troll diagram, it unfortunately is not to scale for time. Time is very long, by the way. A little party trick you can try, and you can try it right now if you're not going to hit your neighbor. If you put out your arms, and we call your right middle finger, the end of your right middle finger, 4.56 billion years ago, and the other middle finger is right now, we would say that the beginning of life is right here, little single-celled organisms. The beginning of complex life is about right here. The beginning of the dinosaurs is right here. And mosasaurs exist for about this amount of time, which is actually a lot longer than we've been around. So if you want an idea of how long we've been around, if you bite your nails, it'll be the amount of time that it fits in the skin that goes past your nail. If you don't have ridiculously long fingernails, it would be the amount of time that would be the length of your fingernail past that skin. So we are not a very long-lived species yet, and if we keep acting this way, we might not be. So where did mosasaurs live? Well, they lived here, and here, and here, and here, and here, and here, and here. Anywhere where there's blue, basically, they lived. Mosasaurs ended up inhabiting the entire planet, all of the seas and oceans during the late Cretaceous. But I focus specifically on the mosasaurs in here, mostly because I don't have the money for traveling worldwide. So this is what we call the Western Interior Seaway. It was a shallow sea that existed at the end of the Cretaceous period, which stretched from the Gulf of Mexico up to the Arctic Ocean. It was home to a lot of animals that are both familiar to you today, like corals and clams and fish, and other animals that are not familiar to you, like sea turtles that are the size of cars, or plesiosaurs, and of course, our mosasaurs. So today, I am going to introduce you to one special mosasaur named Blue Boy. Blue Boy, Blue Boy is going to be handled by Matt, who is going to be his handler for today. Matt is very good at her job, except for I've got one small complaint. Every now and then, she does let Blue Boy do this kind of inconvenient thing where he comes up and bites my face.
He's teething.
He's a reptile. They teeth through their entire life. Oh my gosh. Well, so because I can't rely on her to stop Blue Boy from biting me on the face, if he comes over and tries, I'm going to need you guys to shout sea lizard so that I know that he's coming.
Sea lizard.
Stop! Okay. So, speaking of Blue Boy's needlessly aggressive behaviors, that is actually what I study. Aggressive behaviors in mosasaurs. This is called agonism when we talk about it in animal behavior. That would be anything from aggressive displays, biting, wrestling, etc. Any aggressive competition behavior in animals is called agonism. And I study that agonism through, is this working? Oh, shoot, there we go. Bite marks that are on their skull elements. So there's a lot of bite marks on a lot of mosasaur skulls. And the reason that we know that they come from other mosasaurs is for A, because there's nothing that mosasaurs lived with that's really big enough to be picking fights with them other than other mosasaurs, and B, we kind of find their teeth in there sometimes. That's kind of a smoking gun, that one, and usually they come from the same species. And so I am not the first person to talk about mosasaurs biting each other. There have been quite a few publications talking about that, but so far, at most, those publications have used 3 specimens, and they've made a lot of behavioral interpretations, some of which I would call overinterpretation just based on the sample size that they have. But that's the scientific process. They've done their science. Now I'm doing science that I think might be better science. So, speaking of overinterpretation, in science, if you make a claim, you have to provide evidence that is directly proportional to the greatness of that claim. So, in essence, extraordinary claims require extraordinary evidence. So if I provide you with the interpretation, based on the information that I've given you so far, that the bites on mosasaur skulls result from combat between males, would we call that overinterpretation? Yeah, that's definitely overinterpretation. I haven't gone through the scientific process with you yet. So the scientific process is something you probably all learned in school, and it probably looks a little bit something like this. It's pretty simple. Make an observation, develop a research question, read about what has already been published on that, form a hypothesis, conduct your tests, and interpret whether the results support or contradict your hypothesis, then communicate your results. That is, in essence, the scientific process, but in the professional field of science, we do a lot more. It's actually quite exhaustive. It involves looking for funding. It involves making it through peer review and doing conflict of interest statements, et cetera, et cetera. This can take years, and for me, so far, it has taken 2 years, and only one of my 3 papers is actually under review so far. I still have yet to submit 2 more. So it's very exhaustive, and it's very exhausting because of how rigorous it is. That's why it's not fun when we get people who have never actually studied your topic doing this. I'm not fond of that, and that is because usually it is not based on a lot of information. They do have one point, though. Science is imperfect. And what I mean by that is that we are always building on our knowledge. You'll hear a lot that, like, well, they used to say this, but now they say this. It's not that science lied to you or even necessarily was outright wrong. It's that we got more information and we built our interpretation. But the problem is, we will never reach the point where we know everything. And the reason for that is that every time we answer a question, a dozen more come up. And that's how it'll always be. We'll never run out of questions to ask, but that's part of the fun of science. So, I'm actually going to have you guys participate in the scientific process today. So your job will be to be my peer reviewers. Please don't interrupt while I'm talking. We will have a chance for you to be my peer reviewers. So throughout my next portion of this talk, I want you to analyze my work critically, look for flaws in my logic methods or results, if any, provide suggestions for improvement, and question my reasoning where it doesn't make sense. And once we've done that, I will better explain or adjust accordingly. Excuse me. So, we'll start with our research question. That's the first step of our scientific process. Can trends in mosasaur injuries help us to understand how they interacted with one another? And our first hypothesis, our big hypothesis at least, will be if trends can easily and be easily and repeatedly discerned from bite-inflicted injuries on mosasaur skulls, they likely represent a repeated and regular social behavior rather than random conflicts with contemporary animals. Now, this first main hypothesis is only one small part of my overall research. I will not be presenting all of my research today because that would take more than the hour that I have. But we don't just have the one big hypothesis. Each hypothesis has to be tested with smaller hypotheses. So usually we would set up mini hypotheses which involve a null hypothesis and an alternate hypothesis. Our null hypothesis is a hypothesis that is designed to basically disprove our bigger hypothesis. So that's the thing about science that a lot of people don't understand. We're not trying to prove our hypothesis, we're trying to disprove it. And we only consider it true if it survives our attempts to disprove ourselves. So in order to do any of these, I needed to start with a lot of mosasaur specimens. So I went to 17 museums across the United States and Canada. No, sorry, 18. I recounted and there was 18. And after doing that, I found that I was able to find 244 individual mosasaur specimens, across which had a total of over 2,200 individual skull bones. That's a lot of bones, and that's a lot of data, which makes this the largest mosasaur survey conducted for a single study. That's kind of a big accomplishment. I'm kind of proud of it. So we'll start with our first mini hypothesis, and that would be that all injuries observed on a given skull show the same healing progress. All right, well, let's take a look. Whoop. So, who here has ever broken a bone? Quite a few people. Mark has broken bones right now. So it took a while to heal, didn't it? And we wouldn't assume that, it just went from being broken to healed, right? There was a process of healing that it went through. Mark, if we scanned him right now, we would see that he has undergone some level of healing already. So that happens to be true of our fossils as well. We can actually see the damage at different progress levels. So lizards, get out of here. Go! Thank you. So lizards heal differently than we do. And so I had to compare my ancient lizard to healing on modern lizards. And I did that by taking these little silicon impression molds, this little green goo that would solidify, and then I'd peel it off. And I put it under this microscope called a Lex-T, which is a little laser microscope. You see that little laser there that scans these peels at microscopic detail. Basically, what I found is that mosasaur healing progression looks exactly the same as its modern relatives, which makes quite a lot of sense. I also found that a lot of mosasaurs actually have multiple stages of healing. This is one specimen from Timber Lake, South Dakota, which has an injury that is barely healed, an injury that is pretty healed, an injury that is mostly healed, an injury that is pretty much completely healed and just a scar, and cancer. Yeah, so sorry for this guy. I'm not sure yet if this is part of what killed him or if it was that final blow. But all I do know is that he had a few injuries that were just a little bit along their progression when he died. And I find that that's actually true of most of my specimens that have bites. They usually have multiple bite marks at multiple healing stages, meaning that they came to blow with other contemporaries multiple times before they died. So we actually reject our null hypothesis and support our new alternate hypothesis. Most bitten specimens show multiple stages of healing. Moving on, our next null hypothesis would be that biters are larger than victims of biting. So we tend to think of animals that bite other animals as bullies, right? We like to personify them that way. The truth is there's not always a bully. Sometimes it's just two animals that are going head to head. But we'll see if that holds up. So basically, I looked at where there were potentially correlated bites, and I measured the distance between them and the distance between the teeth on the individual that they were found on. And then I compared the two. And when I did that, I found something I didn't really expect. It seemed like they kind of skewed smaller than the individuals that was bitten. That's a little weird. I mean, like we think of small dog syndrome, right? Where like your Chihuahuas are more aggressive than your German Shepherds, or sometimes it's true of people as well. But it's not a lot of that going on in lizards. So I was like, that's a little bit bizarre. So I decided to look at it a different way. How many people have ever been bitten by an animal? I sure have. When that animal bit you, did it bite you with the front of its mouth or the back of its mouth? Probably the front of its mouth, right? Because it's a lot easier for it to bite you that way. So in mosasaurs, the teeth on the front of the mouth are smaller than the teeth towards the back, or the distance between the teeth is smaller than in the teeth in the back of the mouth. So when I only consider the teeth on this foremost element called the premaxilla, suddenly it skews larger. So I'm like, oh, okay, so we're looking at a material bias. And what I realized was that this stuff that I was looking at, I was basing it off of all of the bitten specimens, some of which don't have complete tooth rows. Okay, well that creates an inherent data bias. So what happens if I only include the specimens that have complete tooth rows? Well, suddenly, all of those individuals that seem like they're smaller than the individuals that were bitten go away. And I just keep my guys where the bite marks are within the range of spacing of the teeth on the individual that was bitten. In essence, I took the smallest tooth spacing and the largest tooth spacing, and I looked at where the bite mark spacing fit, and almost always, when I use complete tooth rows, it fits somewhere in that range, which implies that the biting mosasaurs might be pretty close in size to the bitten mosasaurs. So we reject our null hypothesis, and we present a new alternate hypothesis. Biters tend to be within a similar size range as victims of biting. Finally, our new null hypothesis, smaller individuals are more likely to possess bite marks than larger individuals. I guess we tend to think of a lot of the biting things as potentially being predation, right? I mean, lizards prey on smaller lizards all the time. Why wouldn't that be true here? But we have to see if that's true. So as I said, mosasaurs are quite diverse in size, and so it's hard for me to assess them as an entire group based on all of these, because if I look at the size of this guy versus the size of this guy, they're just going to fall in completely different categories when I look at the adult individuals. So I had to standardize. I created species size classes. So the largest individuals of our Dillosaurus would be in the same size class as the largest individuals of our Mosasaurus hoffmanni, in spite of being completely different. But those are the largest sizes for their species. And so once I've gotten done standardizing, when I look at it, I actually find that, ooh, the smaller guys have no bites at all, not even the unhealed ones. That's kind of weird. That means that they're not really probably being preyed on much at all. But then you see this frequency increase with size. So that got me wondering, well, what about the number of bites per bitten individual? But to do that, I had to increase the data resolution. So I was splitting them into 6 size bins, but I decided to switch to 20 size bins, yeah. And when I did that, I actually found that the same was true. They seem to increase in number of bites per individual with size. Ignore this space for now. That's a different question. But it is scientifically relevant. So smaller individuals is actually, we reject that null hypothesis because it is actually larger individuals that seem more likely to possess bite marks than smaller individuals. So let's go through what we've figured out so far. Bite injuries on mosasaurs can be visually identified and often exhibit multiple stages of healing. Mosasaurs were being bitten by individuals who were in a similar size range to them, and individuals possessing pathological features are most commonly large adults. Okay, what does that all mean? So in paleontology, we have to, because we're studying the behavior of an animal, right? So we have to consider what it's related to. And in geology, all geological sciences, we have a big rule that we follow. The present is the key to the past. So basically what that means is that the things that we observe happening as rules today were probably rules in the past, and that goes for behavior as well. So how many people have ever seen a video of a tiger or a mountain lion or a lion that doesn't know that it's being filmed? Yeah, a few people. It kind of acted like a cat, right? You might have found yourself pointing at this large predator and saying, that's a kitty. Well, it's acting like a kitty because essentially it is very closely related to your house cats. Animals retain behaviors to their closer related relatives. How many people in here like to hug somebody for comfort, somebody that they care about? It should pretty much be everybody. Well, that's true of all primates too. So you think that a lot of your behaviors are unique to humanity. Actually, they're long-term evolutionary traits for primates. And we would assume that the same would be true of mosasaurs, who once again are toxicophoran lizards. So if we look at the behaviors of toxicophoran lizards, we see that while other reptiles like alligators, who are not very closely related to mosasaurs, will bite each other for territory or resources or mating, or sometimes just because they're hungry, our toxicophoran lizards almost exclusively fight each other for mating rights among males. Interesting, interesting. That's true of both these varanid lizards and snakes. This is not a snake skull. I know that's kind of lined up weird. Snakes actually, I cannot look at the bite marks on their skulls because of the fact that they do not actually bite hard enough to create those sorts of marks. Their jaws are just not built for that. However, monitor lizards, like our Komodo dragons, I could look at. And actually, we're seeing a pretty similar trend in the location and frequency of those bite marks on monitor skulls that we see to mosasaur skulls. Again, another interesting point. And finally, snakes and monitor lizards reach maturity at about the same relative size ranges as mosasaurs, and that is true regardless of which group. So I now present you again with an interpretation that most bite marks observed on mosasaur skulls result from ritualistic mating rights combat, as it does in modern relatives of the mosasaurs, i.e. the big lizards act like big lizards. However, notice that I say it may imply, and that is because, unfortunately, I'm not a time traveler and I can't go see what they were actually doing. Mosasaurs are pretty unique among lizards. Get out of here. Go. Go. Thanks, guys. I'm tired of the scars from that guy. So, may imply. That's where I was. Sorry, I lost my train of thought there. So basically, because I cannot go back in time and observe what that lizard was doing, I have to take every interpretation that I say, regardless of how certain I am, regardless of how well the data matches up with that of modern lizards, I have to take it with a grain of salt. And I have to present it with a grain of salt, because even though what I presented seems to match up with the data, that doesn't mean that better data won't come along one day and completely disprove me. So now I think I'm ready to submit to my peer reviewers. Okay, it's off. All right, so I need 5 volunteers. I was hoping for more kids in the audience tonight. But so I'm going to make preference for kids who want to be scientists, if there are any in here. By a show of hands? Okay, anybody else who wants to be a peer reviewer who is not already a scientist? Oh, I don't have any peer reviewers. Oh my gosh. Okay, there's one. Okay, you in the back. So if I can get at least you two, is there anybody else? Nobody? Oh man, you guys are making me sad. There are prizes involved. Okay, Nikki, you can come up. All right, you, oh yeah, okay, one more. There we go, there we go. All right, there's space for one more person. Nobody? All right, if you 4 would come up and line up for me, that would be perfect. Facing me, just down here, I will call you up one at a time. Yeah, well, why don't you come up first? Thank you, Andy. Don't be so scared. I'm not going to bite you. I'm not Blue Boy. Okay, so Andy, I have a question for you. Are my conclusions overinterpreted?
To my knowledge, I would say no. I think that you have fairly proven your conclusions.
Are there flaws that you notice in my data?
I guess I feel like there could be more proof of I feel like you're heavily relying on, current trends in lizards and snakes, and I maybe would like more data.
Okay, good to know.
About how to prove that more, I guess.
Great. Do you have any suggestions for how I can improve that research?
Maybe more samples.
More samples?
Although
Oh
it sounds
boy.
like you've got all the samples possible.
And finally, anything else that you want to ask Ad to bring up?
I will say, I noticed in the trend that the most aggressiveness was kind of right after they reached maturity, but it tailed off at the end. It seemed like the very largest, like the most mature, seemed less aggressive and had less bite marks. Why is that?
I'm so glad that you asked that. I don't know if I want to spoil it. Maybe I should let people read the paper when it comes out. Because that's actually the most interesting thing that's coming out of this paper, is I'm about to say, oh really? Oh, okay. Well, I guess I can tell you guys a little bit of a thing. So, in a lot of reptiles, females are bigger than males. So we might be looking at some species of mosasaur where the females are bigger than the males, and thus they would not have any bite marks. Again, I have to present that with a grain of salt. Okay, get out of here. Next person. Hello, Nikki.
Hi. Hello.
Are my inclusions overinterpretation?
I don't think so.
Okay. Are there flaws that you notice in my logic or data?
Like Andy, the modern interpretation of the lizard behavior, especially the monitor lizard, I'm not that familiar with it myself, but it would be interesting to see what happened, especially as they got older.
Yeah.
If you compared it based on their ages or not.
That is awesome. Yeah, I'd love to do that in future research. Okay. And do you have any suggestions for how I can improve? I guess that was one.
That was, yeah.
Anything else you want to ask Ad to bring up?
No, but I really like your hat.
Thank you. I like my hat too. All right, next up. Whoever's brave enough. What's your name?
I'm Catherine.
Okay, Catherine. Are my conclusions over interpretation?
I don't think so, no.
Okay. Are there flaws that you notice in my logic or data?
I am totally not into science, so my answer is going to be no, but I can see where they're coming from with saying relying on the modern.
Thank you for participating in science, regardless of not being very familiar.
I think it's interesting.
It is. I love it.
Very interesting.
Do you have any suggestions for? I guess that was one again, but do you have any other ones?
Well, I mean, you looked at all that was out there, so I don't know how.
As much as I could, anyway.
As you can,
Yeah.
You can't travel to the other countries.
I am a very poor grad student, so. And
You did a lot of research, so I think there's that.
thank you. And is there anything else you want to ask, add, or bring up?
No, I think you did a lot of
Okay.
research. I think it's cool.
Thank you. All right. And finally, what's your name?
I'm
Jackie?
Jackie.
Okay, Jackie. Are my conclusions overinterpretation?
I don't think so.
Okay. Are there flaws that you notice in my logic or data?
Not necessarily a flaw, but it wasn't easy for me to make a direct connection to when the snakes came in.
Okay. Yeah. Mosasaurs are very closely related to snakes. That was so. I look at snake behavior and I look at other toxicophoran lizard behavior, and I basically look at where there are consistencies. And because mosasaurs fit somewhere in that group, we would expect that any consistencies between snakes and monitor lizards should also show up in the group that fits kind of in between the mosasaurs. So that's why we've got our snakes and our monitor lizards.
For some reason, I was thinking they were different categories. So.
Oh, yeah.
And that's because I'm a scientist.
That's okay. That's okay. I appreciate you for participating in the scientific process. Are there? Oh, sorry, I just asked that one. Do you have suggestions for how I can improve this research?
I don't think so.
Okay.
You've done a fantastic job.
And anything else you want to ask, add, or bring up?
Yes, I want to ask, what was your favorite museum that you visited out of the 18 locations?
That is so hard. I think, because it was my favorite when I was a kid, going to the Field Museum in Chicago was just such a dream come true. Getting to do research at the place where I used to go when I was 8 years old to see the T-Rex.
You're probably dreaming of doing this.
I was freaking out. It was so great.
That's amazing. Very cool.
Thank you, Jackie.
You're welcome. Thank you.
Okay.
Well, excuse me.
Okay. Oh, I forgot to. Do you want to hand these out to the peer reviewers? Yeah. Okay. Okay. So I'll get to questions soon. So why does it even matter? Why does it matter how this extinct sea lizard was behaving? Well, science builds on science. Research builds on research. While this one question might seem relatively irrelevant, it adds to the larger puzzle of how does behavior evolve? And that's a very important thing right now, especially because, and this is where I get on my soapbox, the Earth has a fever. We caused it. That is pretty settled at this point. Temperatures are rising higher than they have in all of human history, and in fact, the only time in prehistory temperatures have risen this fast is around mass extinctions, which we are currently in the 6th of right now. There have only been 5 so far. This is number 6. Unfortunately, species extinction rates are significantly higher than the background rate, the natural rate that we should see, and it seems to increase with human population. The main cause is habitat loss. So while climate change hasn't been the main factor for species extinction yet, it is quickly becoming one because it is causing habitats to change. They are changing more rapidly than animals can adapt to, and because of that, these animals are going to be changing their behaviors, potentially not quick enough. So if I can study how behavior evolves in the past, maybe I can help find a way to mitigate how those behaviors might be counterproductive to their survival as their environments change faster than they can. But I mean, what am I talking about, right? After all, we have every right to this planet. What other species could come up with milk that you drink as an adult from another animal? Or news that admits to lying to you but you listen to anyway? Milk that you eat instead of drink? Mel Gibson. Milk that you could either eat or drink? The most annoying method of transportation. A milk that does not come from things that should be making milk. What is with people in milk? Whatever that is. and the worst thing that could have ever possibly been made, and then enough of them to destroy everything for some reason. Yeah, I think that we've definitely been responsible caretakers of this planet that we share with everybody else. So anyway, I don't know about you guys, but my mom taught me that when I make a mess, I need to clean it up. And I think that we've made a mess, and I want to contribute to cleaning it up. But to do that, to kind of complete my goal of using the study of evolution of behavior to help animals to survive these drastic environmental shifts that we're seeing, I need a lot of fossils. More fossils than we already have from over 200 years of collecting. And unfortunately, there's not enough paleontologists out there to do that. And that's where citizen scientists, like potentially all of you, come in. So on the topic of mosasaurs, there is a place in this very park where mosasaurs can be found. It is in the lowest beds of rock that are in this park. The gray beds and the sandstones above them are land sediments. So we would not expect to find mosasaurs there. And above that, these are significantly too young for mosasaurs. And above that, there's lava. You don't find fossils in lava. Oh, right. And what I tell my students all the time is that if you find a mosasaur, I will buy you ice cream. So at the end, you will see my contact info. If you do spot a mosasaur in this park, let me know. I will buy you ice cream. This could be you. So where would you do that in this park? Well, there actually are several trails where you might find mosasaurs. Basically, if you just follow these trails and look on the ground, you have a chance of finding a mosasaur. None have been found in this park yet. That would make it highly scientifically significant. However, you cannot go off trail and you cannot go digging. This is a national park. That means that nothing can be picked up off the trails or out of the ground. But if you find something that looks a little bit like this, in rocks that look a little bit like this was in South Dakota. This is not on public land. This was on farmland that we had permission to be on. Do not do this in a national park. If you find something like this, what you can do to help is you can follow this list of steps. You can keep an eye out for fossils on your local public lands. When or if you find one, don't touch it, leave it in place. That might be the most important part, because we need to know exactly which rocks the fossil comes from in order to be able to effectively study it. Photograph the fossil and use something for scale. That could be a penny or a quarter or a pencil or ideally a ruler. Don't use your hands. My hands are different size than your hands. That's not going to tell us much. And don't use your boot. My boots are different size than your boots. That's also not going to tell us much. And finally, take notes where you found the fossil. The coordinates would be the most helpful. If you've got an iPhone, you can actually go to your compass app. One sec. I swear to God, I have it here. Yes, there it is. And it's actually got coordinates at the bottom. You take a screenshot of that. Whoop, that just turned it off. That's okay. And then you either email it to the rangers or you bring that information to the rangers yourself. And then they will go out and deal with that specimen. But the big thing here in Bryce Canyon is that no mosasaur has ever been found. And this is some of the earliest rocks that mosasaurs can be found in. So finding mosasaurs in those rocks is important for understanding their evolution. That's why we need citizen scientists like you to help with that. And it's not just a thankless job. As a good citizen scientist, your name will be associated with that fossil forever, like it was with this family in Badlands that found a mosasaur. And Badlands actually was very thankful. They made posts, they put their picture on the wall, etc. So there's a little bit of glory with it. And then you also get the joy of knowing that whether it goes on display or goes into a collection for research, you have contributed to something that benefits everybody. Fossils are something that everybody pretty much enjoys. Who here enjoys fossils? I mean, you're here, right? Yeah, exactly. Who here likes going to museums to see fossils? Who here likes watching things about fossils on TV? Whatever, right? Like finding fossils contributes to that joy that everybody gets to partake in, and the knowledge that we all get to have about the history of our planet. So be a good citizen scientist on public lands, please and thank you. And make protecting your public lands patriotic again. Thank you very much. So now I will open the floor to questions. And, oh, okay. Whoop. But he did not bite me. I will open the floor now to questions.